Hello friends, welcome back once again after a very long time, and here we have a very interesting question. This is very simple concept we always used while learning derivative or solving any type of the problem related to the derivative or even integration, but we never wondered, we never learned why it is so. We always say that derivative of a constant is always zero, and yes, that's absolutely right. But why it is so, right? So we're gonna learn that. That I'm going to tell you first by theoretically, and then later I'll prove it. Right. So before starting, I have to tell you once again, we need to know the concept of derivative. What is derivative? Because in the definition of the derivative only you can understand why the derivative of a constant is zero. Right. Derivative means like the rate of change of a thing when another thing get changed, like how rate of a one thing get changed when another thing is changing. It's something. I'm loosely defining it. I'm just trying to make you understand. Let's say I have a function something like this. All right, let's say this function f of x equals to something, whatever. Let's say x square plus 3x, whatever it is. So in this case, I'm not directly writing, right? It's not an exact function, but just to understand, I'm doing this. So in this case, if in this case, if you change the value of x, in the place of x, if you put, let's say, x plus 9 or whatever, if you change the value of x, this entire thing also changes. So as the value of x get changes, the y value is also getting changes. This is y. So as x is moving, you can see the value of y is also, sometime it is here. When x is here, y is here. When x is here, y is here. When x is here, y person is here. So see, you can take a look. Right. So when x is here, I'm going to say when x length you're moving this much, then y length is also increasing. So as you see, as you see here, as x length is increasing, y length is here also increasing. As x length is increasing, y length is increasing. As x length is increasing, y length is increasing. So overall x is also changing, and the whole value, this is called y also, y is also changing. So what is the rate of change of y with respect to x? I'm going to say what is the change in y when x get changed. F prime of x, or you can also write like the derivative of f of x with respect to x, anyhow you write. So overall it is changing. It is telling us that what is the rate in the change of the value of y when x value, when you're going to put the measure here, that is changing continuously. Right. So overall it's rate. Now we have here something different thing. This time we have here constant function. Why the derivative of a constant? Let's say for a while our function f of x equals to a constant like 2 or 3 or 5, like. So for a while, let's say it is some constant, a numeric, let's say it's c. Right. C means a constant. Okay. So in this case, let me try to draw a small graph. All right, let's say f of x equals to c, which you can also write as a y. Right. Generally people write this side. Okay, so y equals to c is our function. So y value is constant. Let's say this is our y, this is our x-axis. So y value is constant, let's say here. All right, so it will be pretty straight line. Keep in mind I said pretty straight line. All right, so y equals to c, that's our constant. So when I'm changing, see here, when I was here, let's say this much value of x, let's say this is x1, then the value of y is, let's say, y1. And when I'm at this point, let's say this is x2, then the y value is here, let's say y2. When it is x3, the y value is again here, let's say y3. Let's say I went to negative side, x4, and y value is again here, y4. Now my dear friend, you tell me, is there any difference in the value of y1, y2, y3 and y4? These all are same. Y1 is equals to y2, y2 is equals to y3, y1 is equals to again y4. So overall all the value of y is same. So however the value of x is changing, though you're changing x, wherever you go in positive or you go in negative, the value of y is constant, means y is not changing. So there is no change. There is no change dy over dx. That's why there is 0. There is no change in y. There is no change in y when I change the value of x. Did you get what I mean to say? Yes. Now let's try to prove it. It's like f of x equals to constant. Okay, I'm telling you here proof. How do you prove in your notebook? So f of x equals to constant. As I said, the function never changes when you put the value of x as a different. When you insert any different value, you'll get always constant. So what I'm going to do now, I'm going to make a small change in x. Let's say x plus h. Here h is a very small change that is constant. Some people also write in their school as x plus delta x. All right. So whatever you write, it's your wish. Constant. All right. No problem now. So how we have defined the derivative, the derivative of a function f of x, how we have defined in the by the limit definition, it was like limit when h tends to 0. Some people also write here delta x tends to 0, so it's same. All right, don't get confused. F of x plus h minus f of x divided by h. All right, so this is the definition of the limit. All right, so in this thing I'm gonna use my function. All right, in this case I'm gonna use my function, and my function is here. Keep in mind that. So f prime of x is going to be now limit h tends to 0. F of x plus h is equals to c. This is equals to c, and f of x equals to also c, and divided by h. Okay, so it's going to be now limit h tends to 0. Now you might be asking why x plus h equals to 0, like why f of x plus h is 0, because whatever I'm going to insert, I'm going to get constant value. Whether I'm putting this one or this one or any quantity you're going to put here, any value of x, you're going to put here, you'll get c here, constant. So now this constant and this constant get cancelled, 0 over h. All right, so it's going to be like limit h tends to 0 equals to 0. Finally there is 0, so like it's 0. So what did you get here now? F prime of x means the derivative of the function f of x is here 0. All right, so that is why what I can say that now the derivative of the function f of x equals to 0, or same thing you can write derivative of a constant function, f of x, or you can say you can say y with respect to x is 0. All right, so that is why. What is y here? Y equals to constant. That was our function. So further what I can say that derivative of a constant equals to 0. All right, so derivative, this constant can be anything, in the place of this constant you can put anything, like derivative of a 2 with respect to x or any other quantity equals to 0. Derivative of, let's say, 999 with respect to x for a while or y, anything equals to 0. Let's say derivative of negative, positive, any number you put, any real number or any constant value, that is always 0. Keep in mind, derivative of pi, what is that? That's always 0. And you know the reason, because when the function is constant, that time the line will be pretty straight, and since line is pretty straight, so there is no change in line as the value get changes. Wherever you go, the line will be pretty straight. So as the line is pretty straight, function is not changing, so how the derivative will be something different, it will be definitely 0. I hope you understand it, and if there is any more confusion or any doubt, then please feel free to comment below this video. I'll be really happy, and please subscribe the channel and hit the like button. Bye bye.